Hello viewers, this is a new presentation on locomotive parameters which are measured in case of derailments. I have shown its maximum and minimum permissible limits as given in the mechanical code books, manuals, circulars and RDSO maintenance instructions. Loco derailments are of many types like midsection, while entering loop lines, over turnouts, etc. So each derailment has to be dealt according to its nature of derailment. In this video, the joint measurements are discussed with respect to the prescribed limits as a ready reference for the PV engineers so that they need not have to search or browse the required data. I have tried to put it in a consolidated form in this video itself. And this is the PROFORMA for locomotive power measurements. Annex A and serial number 1 is on basic information about the train number, loco class, loco number, etc. Serial number 2 gives a brief particulars of safety items not provided, but missing or not working, or whether loco is provided with headlight, speedometer, speed recorder, flash recorder, horn, brake system, etc. These are all basically information particulars to be recorded jointly. Serial number 3 gives instructions to check and record observation like position of controls, handles, cutouts, blocks, then function of brake, synchronizing valve, position of brake blocks after the accident, whether they are in applied condition or not, then condition of kettle guard, any sign or seizure of any roller bearing in axle boxes including condition of its component. We have condition of pivot and side bearer arrangement of bogie including obstruction to bogie rotation. This cannot be seen in the block section until and unless we go to a particular shed and get the body lifted. We have condition of friction dampers, component hydraulic dampers, condition of traction rod, guide rod including its connection. Similarly, we have condition of lateral stop, components between bogie and loco body under the frame. This is the most important parameter which need to be looked after in case of derailments, because the vertical clearance of the stops gives a fair indication about the suspension system of the locomotive. And then we have any other observation in respect to mechanical defect of the locomotive which might have any bearing on the safe running of the. We move on to the measurement part of the locomotive. So in this we have serial number 1 is particular of axle ID number. This is more relevant in case of axle breakage or roller bearing failure. Item 2, most important one, the diameter of the wheel head tread. Now in this fashion we record the wheel diameter. So on the left hand side in the direction of locomotive we record as L1, L2, L3, L4, and similarly on right hand side we measure the wheel diameter recorded as L1 to L6. Now reference I have taken from final speed certificate and the manuals. So between two axles on the same axle, the wheel dia should not exceed 1.6 millimeter, as I have shown here. And between axles within a bogie, either the front or the rear, it should not be more than 6.4 millimeter. And between front bogie and rear bogie, there are two bogies, having set of 3 axles each. So on 6 axles the variation should not be more than 31.8 mm. So I repeat, on the same axle it's 1.6, on the same bogie it's 6.4, and on the LOCO it's 31.8, which is the maximum permissible limit, and the minimum wheel dia shouldn't be less than 1016, as minimum wheel diameter approximately prescribed is 1016 millimeter. Serial number 3 is wheel flange thickness, and serial number 4 the wheel root wear. So the maximum limits prescribed are: for root it's 6 mm, flange 3 mm, tread 6.5 mm, and this is the flange wear gauge. We measure it. So we place the gauge like this way, and the reading is taken over here for flange wear. Serial number 5 is tread wear, and 6 is UST, ultrasonic testing of the axle, and this is another gauge which gives tread wear, flange wear and the root wear. So this is a combined gauge for tread wear gauge, we call it, but we can take these 2-3 parameters here itself. So 1, 2 and 3. This PROFORMA is measurement for wheels for all classes of locomotive with wheel gauge. 04 location applicable for Bobo locos. This is continuation of the previous annexure, and now here they have mentioned some notes how to note and record the wheel number. So wheel number 1 is the outer end axle of truck under the short hood, and wheel count increases towards the long hood on diesel loco. Whereas for electric loco, wheel number is 1, that is, wheel number 1 is the outer end axle under cabin 1, and that side of loco which has compressor, and cabin 2 is that side of the loco which has the Arno converter, and wheel count increases towards cab 2. So there are 2 types of locomotive. One is diesel locomotive. So the numbering as stated in this paragraph is that from short hood, the end axle is axle number 1, followed by axle 2, axle 3, axle 4 towards long hood side. Whereas in case of electric loco, we have mentioned as cabin 1 and cabin 2, mean cab 1, cab 2. So starting from outer end axle of cab 1, that is notified as axle 1, and then subsequently axle 2, axle 3, axle 4 and so on up to cab 2. And then how to record the measurements? So they have given the drawing numbers. This is SKDL 3592 for all BG locomotives except WAP3. For WAP5, the RDSO drawing number is SKDL 4446 and SKDL 4447 to be followed. So all measurements are taken by placing the loco on level track so that there are no variations. And service limit, what they mention given in the maintenance manual, are for only maintenance practices. These are not safety limits. However, the measured values shall be compared with the service limit, and degradation in values shall be discussed while finalizing the findings. So we have service limits also, so we have to go by the service limits provided in the manual for finalizing the cause of derailment. Serial number 7 for checking wheel gauge, 3 measurements at equal spacing on the inner periphery of the two wheels on same axle is to be recorded, and we need to check out for any bend or so. So this is the gauge we use, and this is a enlarged view of the reading given over here. And this is the process of measuring the wheel gauge in the pit line. The maximum limit and minimum limits are given as 1596 plus minus 0.5, and the service limit is minus 0.52 plus 3 millimeter. Next item is buffer oblique CBC height. Measurement of parameters such as buffer length, etc. may also be done to check the possibility of buffer entanglement. The maximum buffer height from rail level should be within the limits of 1032, 1105, and anything below 1030 and more than 1105 falls under rejection limit. Then we have measurement of other relevant items like lateral clearance. So lateral clearance, this has been specified as first end axles, specifically 1, 3, 4 and 6th axle. So for the end axle, we have to take total of both sides, C1, C2. So the nominal is 6.1, minimum is 4.1, and maximum is 9.1. This is for end axle. And for middle axle, its nominal is 15.7, minimum is 13.7, and maximum is 18.8. Another important parameter is lateral clearance between bogie frame and under frame is 44.5, and vertical clearance between bogie frame and under frame is 16. So this was the most important one for checking. So these vertical and lateral stops are provided in the bogie itself. So we have to just go roughly in the center of each bogie, and then we can find these lateral and vertical stops. Again, we have longitudinal clearances also. So this is except WDP3A, WDG4, WDP4, WDP4B, WAP5, WAP7 and WAG9 locomotives. And the total free lateral axle clearance between lateral thrust pad and bearing adapters, it's for end axle 15.7, and for middle axle it's 25.4. And then we have another type of bogie which is known as HTSC B1 bogie. So for the end axle, the maximum limit prescribed for lateral clearance is 12.7, and for middle axle it's 25.4. So there is a difference between the end axle clearances of HTSC bogie and HTSC B1 bogie. So we have to be very particular while checking these bogies, which type of bogie is existing on a particular loco, so that these two lateral clearances of the end axle do not get mixed. So we have difference of about 3 millimeter in the prescribed limits. Next we have longitudinal clearances. So these are the locomotives where exceptions have been given, and where to measure the maximum values are follows. For WDGA and all these locomotives have been mentioned here. For WDP1, WDP3A, it's 5 mm. And for others, it's 4 mm. So here we take the longitudinal. See here, if we enlarge this view, we can be easily seeing this value. So here this value and this value, these both are to be added for obtaining the total value of longitudinal. Similarly, for right hand side also this value and this value. So both these values are to be added together for end axle as well as for middle axle. And this is another condition of suspension springs: normal, broken, fresh, broken. Now this is one parameter which has been given in the manuals also, and we can check it once the trolley is taken out, and then we can check from rail level the top of the bogie frame, and this is prescribed to be at 1143 millimeter. So this height, if we check, this should be 1143 millimeter. From here also we can check both the wheel diameter condition as well as the spring condition. Reflected height of coil springs after re-railing to be taken on level and uncanted track. So this is normally we can take it at site as well, or we can take it in the loco shed. So this is the deflected height when the loco is normally stabled anywhere on a level track, so we can take it. So this table shows the working height. So working height is normally in which the engine is normally running. So the table gives you for WDG and WDP for it's 428 to 438. The drawing number I have mentioned here is SKVL 751, and here we have for other loco also. So always we refer to the table. Generally this is within this only. So I have found in many cases the working height is less than 428. I have seen 420, 419 like that, and sometimes it is even more than this. So that indicates the springs are stiff or of higher range. Then we have these secondary springs, rubber pads. So the height is 200.5 millimeter, and how to classify this as unserviceable? We have this line mentioned in the manual that lifting of rubber from bonded metal surface is limited to a depth of 12.5 mm only, and or a total length of 100 mm on any one rubber metal interface. So if there is a crack or a separation for 100 mm, or this rubber is lifted from the bonded metal surface to a depth of 12.5, then this has to be replaced, and these are the limits which are, if exceeded, this spring is required to be replaced, means this is rendered as unserviceable. And again it is mentioned here, replace any spring if any layer has a tear or a cut which exceeds 25 mm in length and 6.25 mm in depth, or if the accumulated tears in any layer exceeds 100 mm. And even there is one more parameter, if it has a permanent set of about 10 mm, so it's if it is around 1090 or 198 or 190, then this is liable for rejection. Well viewers, now this is a recording of wheel diameters on a loco which had recently derailed in one of the railways, and I had been involved in that loco measurement. It was somewhere on main line. So when I got these measurements done, to my utter surprise, we can see from the recorded parameter that these are the wheel diameters on left hand side and these are the wheel diameters on right hand side. Now as I mentioned here, a diameter on the same axle more than 1.6 millimeter is a rejection. It is a worn out. Worn out means unserviceable. So here we are having on the same Excel C 1016, 1022 means 5.39, then 1019, 1024 again 4.83, 1017.53 and 1023.19 and so on. So there are two things to be seen over here. One is that this wheel diameter has almost reached the minimum limit, right? And here we have all the wheel diameters on the same Excel exceeding the limit of 1.6 to almost 4.5 times. Another important thing what we need to see is that all the wheels on right hand side are having larger diameter. All the wheels on left hand side are smaller diameter. Now, in case we have a right hand curve, so the curve is like this, a right hand curve, and this is the direction. So what will happen? Because these are larger diameters, they will be pushing the wheel outside. Since these are smaller diameters, so these flanges will be just grazing along with the gauge surface of the outer rail, and as on curve at normal speed, the centrifugal force works towards outside the curve. Okay, so this is an added factor causing huge lateral acceleration and lateral forces towards the outer rail. First is due to speed, it's natural phenomena, and then we had the added factor of these wheels pushing these wheels towards the outer rail. It can derail very easily. The second parameter which was out of tolerances is the lateral clearance, which has exceeded its 9.1 value. So the lateral clearance on end axle is 11, 11, 12, 11, and on the middle axle, which is to be maximum 18.8, it has gone to 19.3, though nominal, but it has exceeded its limit. So the wheels lie at rejection limits, both as far as wheel diameter is concerned and as far as the minimum wheel diameter prescribed is concerned. So this loco was lying at condemnation limit, and the cause of derailment was on this account of poor maintenance of loco wheels. Well friends, thank you for watching. Don't forget to subscribe, like, share and comment down. Thank you.